Today we're going to go over 9.2, converse of the Pythagorean theorem. So we're going to look at the image here. In order to prove that this is going to be a 90-degree triangle, we need to go ahead and do this math right here, where it says that c squared must be equal to a and b squared. So basically the sides need to be the same if we have them squared. So if we look at this triangle right here, triangle ABC, in order for this to be a right triangle, that statement needs to be true. So c squared, b squared, a squared. So if we look at that, this statement is only true if we can prove the math. So I marked those out differently to show you that they are different. The little markings there indicate that they're different, so we can say there. So they're all different size, different measurements. But if this rule is followed, we can say that it's going to be a true statement. So let's go ahead and do some practice here. We're going to go ahead and apply this concept over here to this triangle here. We have a triangle there that it says that the longest side is the square root of, the square root of 113. So we're going to say that in order for this to be a right triangle, we need to say 8 squared plus 7 squared equals the square root of 113. Now again, this entire thing must be squared, and so we do the math. 8 squared is 64. 7 squared is going to be 49. And remember that property of exponents and radicals, that this square root is going to undo the radical. I'm sorry, this square root is going to be undone by the power of 2. So that's going to undo this radical. They undo each other. And so what's left is just 113. And so we're going to have one more step to see if this is true. We add 64 and 49, and it gives us 113. So if that's true, then guess what? We say that we have a 90-degree triangle. So we can say, hey, guess what? This is a 90-degree triangle. That's a poor 90-degree symbol there, but that's how we do that, and it checks out. Down here we have Theorem 9.3, which is Pythagorean inequalities. So now we're talking about inequality symbols there, and we have different outcomes. If we have c squared is less than the squares of the sides summed, then we have an acute. If we have c squared, which is the longest side there, if the longest side is has a larger value than the sum of the short sides squared, then we have an obtuse triangle. So let's go ahead and see if we can apply these theorems to example number 6. Okay, so we can fit this all in one go. So we're going to say that we have 15 squared plus 36 squared equals, again, this entire thing must be squared. Okay, so we have 4 squared and then the square root of 95. Let's see if I can fit 95 in there. 95. It looks like a 4. Let me see if I can fix. Okay, so we have that. We can go to square 15. We square 15. It's going to give us 225. We square 36. It's going to give us a value of 1296. And I'm running out of space there, so I'm going to go down here. If we square this entire thing, we must distribute that 2 to the inside of the 4, and that gives us 16. Okay, times whatever this right here is. And I mean this is we distribute the power of 2 into this radical. Now, because the radical has the same radicand and has the same index, meaning that it's going to be an inverse operation. This power of 2 is going to erase this radical. They undo. It's an inverse. And so we get left with 95. Just some properties of exponents there. So if we add 225 plus 1296, we get 1521. So 1,521. If we multiply 16 times 95, we get 1,520. Now, these statements are not true, so I'm not going to follow up with an equality statement, but I am going to go ahead and do a inequality statement or symbol and saying that this value is bigger, okay? Now, if we have this case where we have 1521 has a larger value, which is the sum of the sides, we look at which scenario is that? So if we look at our theorem over here, okay, where do we have that scenario? Okay, over here we have a squared for this first one over here. For acute, it means that a squared plus b squared must be bigger than c squared. Over here, when we have obtuse, it means that c squared has to be bigger in value. So let's go back over here, and we find that c squared is smaller. If c squared is smaller, this has to be acute. And so we're going to say that this is going to be an acute triangle, meaning it is not 90 degrees. It is not 90 degrees. Okay? So that's how we do that. Now we're going to go ahead and try to do example number 7. Now, if you're a visual person, we can always go ahead and draw the triangle out like that right there. We can say this is not to scale, but we can say that's 3, that's 4, and that's 6. Okay? And we're going to do the same thing. We're going to say 3 squared plus 4 squared equals 6 squared. So again, this is not to scale, but let's see what the numbers tell us. This turns into 9 plus 16 equals 36. Okay? Let's go ahead and finish this. We have 16 plus 9 gives us 25. 25. Oh, there's not an equal sign, so we're going to go ahead and erase that because we don't have a true statement. We have to fix that. So we can say that this time that c, the value of c is bigger. Okay? So the combined sides are smaller. Okay? So c is bigger. So let's go ahead and look over here to tell us, so it can tell us what kind of triangle this is. And so if c is bigger here, right here, c is bigger, then we have an obtuse triangle. So we can say, hey, this is going to be I'm going to abbreviate obtuse. Okay? So it is an obtuse triangle. It is not drawn to scale, but the numbers tell us that it's going to be obtuse. We're going to go ahead and do example number 8, and then it's going to tell us what kind of triangle. Same thing, I like to go ahead and visualize some stuff. So I'm going to go there and then make a triangle there. Again, not to scale. That's 4.3. This is 5.2. This is 6.1. And let's go ahead and do the math and see what the math tells us. So we have 4.3 squared plus 5.2 squared equals 6.1 squared. Okay? Again, for right now, I'm just doing an equal sign because we don't know. In the end, we will modify it if we have to and see if we need to use inequality symbols versus equality symbols. So if we square 4.3, it's going to give us 18.49. If we square 5.2, you know what, I'm going to write a space there, so I'm going to go ahead and erase and try to write smaller. This pen is not that great. So if we square 4.3, we're going to say we're going to get 18.49. And if we square 5.2, we're going to get if we square 5.2, we're going to go ahead and get 27.04. Okay? And we're going to say that we're going to leave the equal symbol out to see if we have a true statement. Oh, you know, we're going to leave it in. We're going to have it equal square root of 6.1. The square root of 6.1 is 37.21. 37.221. So we add those together, and when we combine them, we get 45.53. I'm not going to do any symbols yet. Well, we have 37, again, 0.21. And we can look at which symbol do we need to apply, okay? Which symbol do we need to apply based off our statements? So we can look up here, okay? Where do we have the sides, the square sum of the sides, okay? That's going to be right there, obtuse. So this is going to be an obtuse triangle, and that's how we do that. And again, it's just looking at those theorems, looking at those statements, and we do the math, and it tells us what kind of triangles they are. I hope that was helpful. I need to upgrade my pen because it's like writing with a gigantic thumb. Thank you for watching. If you have any questions, please post them in the comments below.